Hello everyone, welcome back to Digital Art Tutors. And if you have not subscribed the channel yet, please click on the subscribe button and hit on the bell icon to receive future notification. And today I am going to present you the third video tutorial on Grasshopper. Within this tutorial, we are going to learn the process of creating stone case totally using Grasshopper. So without taking much time, let's get started. Okay, so we'll start with now the stone case we can create in different ways, but in this video I'm going to show you the way that I would create the stone case. So the first I'll start with the circle. I'll take the circle component and so it would be placed in the center. So I'm not going to put the center point because this has been taken as 0 as the center. So but I will change the radius. So for that I will insert a number slider. Okay, so this one I'll change to integers and set the values from minimum 1 to maximum 10, and I would commit the changes and I will put that, I will link it to the radius part of the circle. So now I can change the size of the circle here. And the next thing is I'm going to create the offset curve, which will be another curve. I'm not going to use the offset curve command, but I will create another circle using this radius parameter. Now for to do that, what I can do is I will use the math components. This would be the first time I'm going to show this one. I'm going to use the addition component here like this. So for the addition, it will take two inputs, A and B, and it will get the summation of that and output the value. So for this one, I'll take the input as this number side output, and for the B, I'm going to set a value. Even you can put another number side here, but in this case, I will just put 0.9. This would be the thickness of the stone case. So I'll commit the changes. After that I'm going to create another circle here, and I'm going to link this one to here. So you can see whenever I change this slider, now this one I have to put values. It should be from +1 to 10. You can see the changes. Okay, so I'll keep as 2. Okay, the next thing is I'm going to duplicate these two algorithm. I'm going to paste it here, right? So this one again I will I have the circle, but the thing is it is overlapped here, but I want to have the circle somewhere out here, and also I'm going to create kind of a slant here. That means the stone case would be a tapered one, right? For that I will take the offset curve command like this. Now this offset curve command is taking 4 inputs, but in this case I am going to use 2 in fact. So this output will put in here, so you can see there's offset happening. and the distance, of course I can give a number slider. We'll set it as integers and set the values from, let's say, from 1 to maximum is 3. Commit, and I will insert this one to the distance, so I can change this one like this. Okay, right. So the next thing is I'm going to take this circle and again create an offset curve. Now this one is only applicable for this one, this circle. So for this one I have to create another one. So I will duplicate this one, and I will take this number slider here also, but this one I will link with this curve. Now you can see when I increase this one, both two curves getting offset. Right, so it's done. Now the next thing is I need to move these two offset curves to this direction, right? For that I can use the move command, but before applying move command I have to make this curve, it's a curve list coming here, so I'll just put curve component and insert this one to here, and again another curve here, put it like this. Next thing is I can move these two curves using move and I can put this curve to this input, and for this motion I have to put the vector. Let's take it has to go in z-axis, that means I have to take the unit z like this, and I will insert this one. Now you can see it's getting moved, and for the input of this vector I will put a number slider. Again I'll set to integer and put the values as 1 to, let's say 10. Commit, and I'll put this one here, so I can just slide the numbers like this. Okay, now the next thing is I have to move this curve also, so I'll take another move component, or I can use the same, and I will insert this curve here, and I can use the same vector, so both two curves will simultaneously move in z direction. Okay, so the next thing is I'm going to convert this whatever the geometry coming in from output of these move components into curves again, like this, and put this one here. Okay. And put this one here, right? So the next thing is so I'll just move this one a little bit. Okay, so the next thing is I'm going to use some surface commands to create surface. Now for these two curves I can use loft command, loft, and I can input these two curves. This one is shift, so you can see there's a surface being created. Same way I can use loft command to loft these two curves. That means these two, so I'll put loft, and I'll insert these two curves using shift command, and I need to create a surface from this curve to this curve and this curve to this curve. For that I will using there is there's a surface tool command, full surface here. That means it will create a surface between two curves, right? So for this one I will take this curve, and the matching curve would be this curve. That means this one, right? So from this one to B and this one to A. Okay, and the next one is this curve and this curve. Okay, so I'll duplicate this one, place it here, take a relationship connection from here and from here to here. Okay, right, so all the surface has been created. Now the next thing is get them joined together. So I'll put join, and I can connect them all with shift. Like this. So if you have to bake this, and you can see, you can check it like this. Okay, now using these sliders you can change the parameters of the height of the stone case and the curves, the size of the curves likewise. So the next thing is I'm going to do some interesting part. So for the fillet I need to convert this output of the join into geometry. So I'll take geometry component, take this, and I'm going to call fillet edge component. Now for this component it is taking 5 inputs like the shape, the blend, the metric, edges, and the radius of the fillet or the chamfer. So for this one I will insert the shape of shape as this geometry. Okay, so for this blend I will take this component called value list. So this value list I will change, I can edit. I will insert fillet, chamfer, and blend. I can put it to it. I'll remove this fourth one. So I will insert this one here, and for the metrics I'll take you can see there are 3 parameters: rolling ball, edge distance, travel distance. So even I can create a value list here, value list. Again I can edit that. So the first one would be this rolling ball. Rolling ball it will take as the 1. The second one is, so it's edge distance and rail distance. So I edge distance and next one is rail distance. Make it a little bit align. 3. So I'll put that in metric input, and for the edges again I can use value list, and this time I'm going to change it to checklist. So for this one it will have 4 edges, so I'll straight away put that here, but it says this object contains one error. At least single radius is required, so that I have to put radius here. So I'll take number slider, and I'm going to set the minimum as, let's say, 0, maximum as, let's say, 1.1. Commit, and I'll insert that here. So now you can see here this edge has been taken as the number 1, and it is being created a filleted feature. If I bake this one, so I can show it to you. See, it's the chamfer. So let's, I think there's some, this has to be 0, and this one 1, and this one 2. Again here also I have to change that from 0 to 1 and the 2. Okay, so I'll bake this one. Let's see what would be the output. Now you can see it's getting filleted. The radius, the fillet radius, I can change here. So there's just only one edge I have been selected. You can select any of these edges. Sometimes you know, in Rhino also there will be failures in the filleting and chamfer. Same issue is applied here. So you may change the thickness and see what will be the output. Okay, so the next thing is I need to create prongs for this collet or the stone case. For that I would I need to create 2 points here, right? And let's see what not this curve, not this one either. Yeah, I need to create a point from this curve, so I can take point on curve command. Yeah, this one. Okay, so I'll take it from here and select this mid. You can see a point being highlighted here, and I can convert that output into a point. Okay, so I will input this one. So the second point I have to create somewhere here. Let's see what would be my circle. So the next curve would be this after this move, that means the geometry of this. So I'll duplicate this one, put it here, and connect this one to this output, right? And set this to mid, and take that output and put into point like this. So I can see there are 2 points here. So the next thing is I'll mid again. So just move this to take this one, and I'm going to create a line. basically I'll put one line to A and second line to B, and you can see there's a line being created here, but I want to have this line being extended towards the top, towards the z-axis, right? So for that I will take extend curve. Okay, so this output I will insert into the input as C, the curves, and for the type it should be a line. That means it should be T. It's a line. We'll select, and for the I can put another number sider. Let's say I'll just keep it as floatings, and put this as, let's say, 0.5 to 0.5. It's 0.5. Let's say 2 here. Count. So I can put that into this one. Let's see the let's just check this one whether it's working. I have to change that to this one, and just put this value of this one, just disconnect this one first, and put this one to 0, comment, then I can go like this. Okay, so we'll keep it somewhere here. Then I'm going to apply what do you call, I have to offset this curve towards, it should be normal to this curve, towards outside, right? For that I will use offset curve command and input this one. So you can see the offset is being done in y direction, right? But I want to have it in x direction. So for that I can change this plane, set on plane. I will take the plane as should be x z. That means this one, right? Now you can see the offset is happening in correct direction, right? And the distance, of course, I can change, and I can even put a number sider here, so you can change the nudge of that prompt, but in this case I'll just put, let's say, 0.5. All right. Okay, the next thing is applying pipe command to this one, this line. I'll take pipe, put this curve here. You can see a kind of cylinder, kind of pipe is created. I can change the radius. You can put the number side again, but in this case I will put as, let's say, 0.5, like this. If you want, you can change this to 0.4, then it will get nudged a little bit into the stone case. And after this pipe, I can again before that I will apply a pole array that I need to have, in this case 4 prongs here. So I'll put whole array. Okay, another thing is if you want to see what are these parameters, you can straight away go to display and draw full name. So all the components will show with all the inputs full names, right? Okay, for this one I will take this pipe as the object. Number of copies I can for the number of copies in this case it has been taken as 10, but I can put a number side here and set it into integers and set the values as minimum. For a prong setting stone case I can put 3, and for the max let's say 6. So I can link this one to the number of sliders. So I'll take 4 here. But you can see the pole array is not created in the correct direction. For that I have to change the position. It need to take the position as so if it is from the top view I have to take, that means 0. So I'll set this value as 0 like this. Okay, and the center of course it's 0. It has been taken as 0. Right, the next thing is I will now these pipes are not capped yet, so I'll put cap pause. So I'll take this input and it will output the capped one, and I need to fill these prompts, so I can use the same thing I used in here. I'll take this, not the geometry, and take this one and take this list and this number side. Okay, copy, paste, and take it to here. You can see this is being linked here. This geometry. So I'll just input this geometry here, so it will change. Now you can see this filleting is happening, so I can just use the amount I want like this. So after that all these components can be grouped together using group. So I can put this group here, so this one to here, shift this one to here, so I can bake this final output group. Bake. Okay, so if you move this one, so you can get something like this. Okay, so I hope actually this Grasshopper document you can use in anywhere, whenever you create in a prong setting, ring or pendant or whatever. So you can use this stone case. You can straight away import this Grasshopper document using you can open it here, so it will always create this. You can bake it to the whatever the size you want, and the document you have to go to the save as document, and you can periodically save this document as Grasshopper document. Okay, that's all for today. I hope you learned a fair bit of new things out of this, and in next tutorial I hope I can create a ring using I will use this stone case straight away, and let's see what we can do. So I'll put this document as a downloadable link in description sections where you can download it and open it and see what it has. But I'll recommending that you to create this algorithm and save it and use it in future projects. So that's all for today, and if you have not subscribed the channel, please subscribe and hit on the bell icon to receive the future notification.